In this lesson, we will learn partial fraction decomposition, also called making a rational function into partial fractions. The goal is to rewrite a complicated fraction into a sum of simple fractions so that we can understand it and often integrate it easily. Here is the big idea visually. One complicated fraction becomes the sum of easy pieces. On the left, a single big fraction. On the right, a few simpler fractions added together. The denominators on the right are simple building blocks, like linear factors or irreducible quadratics. The four-step plan for partial fractions is as follows. Step 1, check for properness. If the degree of the numerator is greater than or equal to the degree of the denominator, divide first. Step 2, factor the denominator completely into linear factors and irreducible quadratic factors. Step 3, write the template. Use constants like a and b over linear factors, and use a linear numerator like bx plus c over irreducible quadratics. Include repeated powers if needed. Step 4, solve for the constants. You can plug convenient x values for linear factors or equate coefficients. Example 1, distinct linear factors. Decompose the fraction 5x plus 7 over x minus 1 times x plus 2. We write the template a over x minus 1 plus b over x plus 2. Multiply both sides by the denominator. We get 5x plus 7 equals a times x plus 2 plus b times x minus 1. Now use the plug-in method. Let x equal 1 to eliminate b. Then 12 equals 3a. So a equals 4. Let x equal negative 2 to eliminate a. Then negative 3 equals negative 3b. So b equals 1. Therefore, the decomposition is 4 over x minus 1 plus 1 over x plus 2. A quick payoff. If you need the integral, this becomes 4 times the natural log absolute x minus 1 plus the natural log absolute x plus 2 plus a constant. Example 2, improper fraction. Decompose the fraction x squared plus 1 over x squared minus 1. The degree of the numerator equals the degree of the denominator, so we divide first. X squared plus 1 divided by x squared minus 1 is 1 plus 2 over x squared minus 1. Now factor the denominator as x minus 1 times x plus 1. Write 2 over x minus 1 times x plus 1 as a over x minus 1 plus b over x plus 1. Solve for a and b. Plug x equal 1 to get 2 equals 2a, so a equals 1. Plug x equal negative 1 to get 2 equals negative 2b, so b equals negative 1. Therefore, the decomposition is 1 plus 1 over x minus 1 minus 1 over x plus 1. Example 3, a mix of a linear factor and an irreducible quadratic. Consider 3x squared plus 3x plus 5 over x plus 1 times x squared plus 4. Since x squared plus 4 cannot be factored over the reals, we use a linear numerator over it. Write the template a over x plus 1 plus bx plus c over x squared plus 4. Multiply both sides by the denominator and expand the right side. Plug x equals negative 1 to solve for a. We get 5 on the left equals 5. So a equals 1. Now choose x equals 0 to quickly find c. We get 5 equals 4, a plus c. So c equals 1. Choose x equals 1 to solve for b. We get 11 equals 5 plus 2 times b plus c. With c equals 1, that gives 2b equals 4. So b equals 2. Therefore, the decomposition is 1 over x plus 1 plus the quantity 2x plus 1 over x squared plus 4. To summarize, always follow the checklist. Number 1, divide first if needed. Number 2, factor the denominator completely. Number 3, write the correct template with the right types of numerators. Number 4, solve for constants by plugging or by comparing coefficients. With practice, partial fractions become fast and predictable. Great work! You can now make a rational function into partial fractions. Try mixing linear factors, repeated factors, and irreducible quadratics to master the technique.